A lot of the other analysis rely on the electromagnetic radiation spectrum and how it interacts with the molecules. So what you need to remember is that wavelength and frequency are inversely related. So the longer the wavelength, the lower the frequency. Longer, lower. The longer the wavelength, the lower the energy. So wavelength and energy are inversely related. This also means that frequency and energy are directly related. So these two are directly related, while wavelength is always inversely related. We can look at them mathematically using the speed of light, wavelength, and frequency, and that's why they're inversely related. Energy and frequency are directly related through the use of E equals h nu, where h is Planck's constant. We can then do a substitution for the frequency, and we can look at the relationship between energy and wavelength. And so if we take that out of the bottom, we can see that they're on the same side, so they're inversely related. We're not going to do anything with the math, but that's kind of where the basis is. If we were to shoot radio waves at a molecule, the radio waves would cause the nuclei to reverse their spin, which gives information about the environment. So it tells us, or it gives us the NMR, and we will talk about NMR later on. Now, microwaves are used to cause the molecular rotation, and that gives us information about the bond length. So microwaves are used to figure out bond lengths. Infrared causes molecular vibrations, and it tells us information about the bond itself. And we will look at IR spectrums later on in this unit. Now, ultraviolet and visible causes the electron emission. We talked about this back in Unit 2. We also talked about it in MYP. We did the flame test lab. We looked at spectrum, and that's focusing on the UV and the visible. If you fire those things at the atom, the electrons will cause that emission. And then finally, X-rays. They're used to cause transitions within the inner electrons. So ultraviolet and visible are for your valence electrons, the outermost, and then X-rays can cause the same thing by looking at the inner electrons. And X-rays were used a lot with the transition metals to kind of figure out what's happening within there. We won't be looking too much at X-rays, but we will look at infrared and then NMR.